The first four questions are, and really the first page is kind of like what was on the quiz. The first four questions are perpendicular bisector and angle bisector type questions. Now, as I look at like number one, for instance, we know that it's perpendicular, but we don't necessarily know that it's a bisector right away. But because AD and CD are congruent, then we know that AB and CB are congruent. Okay? So based on the information that's given, we may not be able to tell immediately that they're congruent, but we can get there because of the other information that we know. So what we would do here is we would say 5x equals 4x plus 3, and we would solve for x. And I'll tell you the same thing I told you on the quiz. Pay attention to the directions. What are we trying to find? Like for instance on this one, I could ask you to find AB, I could ask you to find CB, I could ask you to find AC, or I could just ask you to find X, right? There would be four different questions that could possibly come up from the same question here. And so depending on what we're asked to find will kind of depend on what we've got and what we need to do. But it's just setting them equal and solving, okay? On number 3, this is an angle bisector problem. Because these two angles are congruent, we know it's split in half. And so therefore we know that these two would also be congruent as long as they're 90 to the sides. And so we would set those two equal, we would solve for x, and we would plug it back in. Okay, so 1, 2, 3, and 4 are very, very similar to one another, and the fact that they are perpendicular and angle bisector type questions. We saw some of those on the quiz. All right, on 5 and 6, you're using the same picture. They just give you a little bit different information on each one. 5 and 6 are circumcenter questions. And there's several things that we know about a circumcenter. First of all, on a circumcenter, we know that E is the midpoint, F is the midpoint, and G is the midpoint of all of those sides. Okay? And so not only is it the midpoint, but it's also perpendicular. So we would say that DG is the perpendicular bisector to AB. Okay? Now, the other thing that we know on a circumcenter is the distance from D to each of the vertices is the same. So I would say something here like AD is equal to CD is equal to BD. Those three lengths are all the same. And that will always be true on a circumcenter. The distance from the point in the middle to the vertex, all three vertex points. Okay? And then you can, based on the information that you're given and based on what I know, I can go about. You should have enough information to get where you need to be, but just pay attention to what you're trying to find. On an in-center here, 7 and 8 are both in-center problems, and you have two different pictures there dealing with the in-center. On this one, notice that ND is perpendicular, but we don't know if D is the midpoint, and on an in-center it's actually not. So that's the big difference between the circumcenter and the in-center. It is still perpendicular, but D is not the midpoint of that side. Same thing for E and F. Okay, and E and F look like that maybe they could be. D is definitely not. But up here, it's the midpoint. On an in-center, it's not. But on an in-center, the three pieces that are congruent here would be these three. And it's going to go to the side. So here, I would say that ND is equal to NE is equal to NF. Those three sides are all congruent. So if I know one, I can find the other two, okay? And we know all three of those are equal. And a lot of times that's what you're going to end up doing. They give, like for instance here, they give me ND and NE, but then they're asking me to find NF. They don't give me any information about NF, but I know that NF is what I'm trying to find, and I also know that NF is the same as those other two. So you're going to find X, you're going to plug it back in, and you're going to use it to find NF. So 7 and 8 are very, very similar to one another. Number 9, this is the centroid problem. 9, 10, and 11 are all centroid problems. I give you a little bit different information on each one, so they're not all exactly the same. But on this one, I would say something like Pn is 2 times QP. These are the 1/3, 2/3 relationship problems. Pn is 2 times bigger than QP. So if I know QP, I take it times 2 to get Pn. In this case, they give me that Qn is 30. If I know the entire length of this segment, which piece do I want to find first? QP or Pn? QP. How would I find QP? Divide by 3, because we know all 3 parts. So to find QP, we're going to take 30 divided by 3, which is 10. And then to find Pn, because it's asking me to find 2 pieces here, we know that Pn is 2 times QP. And since QP is 10, then we know that Pn is 20. And these 2 numbers should add up to equal 30. Okay, so that's on the centroid problem. We don't necessarily have any pieces that are equal, like we do on circumcenter and incenter, so we got to do the 1/3, 2/3 relationships. 10 and 11, like I said, are the same thing. I'm just giving you different information, similar type pictures based on what we're given. Use that information to find everything else. 12 through 17 are all mid-segment problems. And when we have a mid-segment, let's take a look at like number 13. It tells me that JK is a mid-segment. So the fact that JK is a mid-segment, there's several different things that we know here. First of all, J and K are the midpoints of those 2 sides. So J is the halfway point here, K is the halfway point here. And that's really an important piece here, because if JH is 10, then what's FJ got to be? 10, right? Because they're the same. And so that makes X equals 10. That's all there is to it. There's not really any work involved. It's just a matter of looking at the picture, knowing what the mid-segment is, and I know, like when we had big ideas, some people thought that was too easy, right? Well, that's not a bad thing to be too easy, right? Just makes you think, oh, I got to do something else, and not necessarily. You just got to understand what's going on there, okay? The other thing that we know in this picture, and we don't necessarily use this as much, but we know that JK is parallel to FG. The mid-segment is parallel to the side that it doesn't touch. Okay, the other thing that we know on a mid-segment is that FG is 2 times bigger than the mid-segment. So if I tell you that FG is 28, what do I have to do to get to JK? I got to do half of it, okay? So Y would be 28 divided by 2, which would be 14. If I give you the mid-segment, then we just double it to get to the side line. So all of these are just a little bit different information given to us that we have to decide, okay? And just be careful, because we get in the habit of setting things equal, but if I look at like 14 and 15, those are obviously not equal, right? The mid-segment is not equal to that piece out there. So because those are mid-segment problems, then you got to decide, am I multiplying by 2 or am I dividing by 2? Okay, the one that's the hardest, I think, here is number 17. And what I'll tell you here is this one is basically the exact same thing that the extra credit was on the quiz. And I had a lot of people get the extra credit on the quiz. And there was no picture drawn there. And so a lot of people did a really good job of working through and solving that. How you draw the triangle. Like some people get caught up like, what's the triangle look like? Well, all of these look a little bit different, right? So how you draw it really doesn't matter. Where you put the mid-segment really doesn't matter. Okay, I'm going to draw it like this. Okay, do you have to draw it just like that? No, not necessarily. So first of all, G, H, J is my triangle. It tells me that right from the start. Triangle GHJ. A is the midpoint of GH. So there's A. And we know it's the midpoint, so we know those two pieces are congruent. We know that BC is also a mid-segment. Well, BC has to be the midpoints of the other two sides because A is the midpoint of this side, and it doesn't really tell me if B is between H and J or if B is between G and J, so I don't think it really matters. So I'm just going to put B here and C here. Those two could be flip-flopped, though, if you wanted to. And because this is a mid-segment, then I know these two are congruent, and I know these two are congruent, because C and B are the midpoints of those two sides. So the most important thing here is that GH is 2 times CB. This is 2 times longer than the mid-segment. That's what we've just got done talking about on all those problems right before it. When it's a mid-segment, the side of the triangle is 2 times longer than the mid-segment that it's parallel to. And the reason why that's important is because they give me an expression for GH and they give me an expression for CB. So we're going to take these two expressions and we're going to plug them in for GH and CB. Okay, so it's just some algebra here. So GH is really 7z minus 1. CB is 4z minus 3. Parentheses are a really big deal here. If we forget parentheses, we're going to forget to distribute that 2. We've got to take 2 times the whole thing. I can't do anything over here, so this just stays 7z minus 1. Here, I'm going to multiply, and this becomes 8z minus 6. And then we're going to subtract 7z. We're going to add 6. And we get z equals 5. Okay. And I've said it a lot, and I'll continue to say it a lot, but you got to really pay attention to what they're asking us to find. If it said find z, we would be done. But here it says, let's find GA. Well, what's difficult about that is GA is not a side length, right? Or we don't have an expression for GA. GA is just the length of GA. And so what I got to do is I got to take 5 and plug it back in. So the expression that we know is GH. GH is 7z minus 1. So we're going to go 7 times 5 minus 1, which would be 34. So we know this whole length over here is 34, GH. But what does A do to that segment, that side? Splits it in half, right? So 34 divided by 2 would be 17 and 17. So GA would be 17. So what I'll tell you is that some of these, like this one here, needs a lot of work, right? There's really no way for you to get there without doing a little bit of work. Some of these don't take that much work. It just kind of depends on the problem and what we're given. If I look at a problem like up here, like we did, like number 12 would not take any work at all. So some people say, well, how can I show work there? There's really no work to show, okay? About the only thing that you could really do here is say E is the midpoint, so those two are equal. There's nothing really to show, and you've got x equals 6. There's nothing to do other than identifying the picture. What do we know about the picture? How do I use that to help me find what I need? Okay, starting with 18, it's what we've been doing this week. 6, 4, 6, 5, and 6, 6 have talked a lot about comparing lengths of sides, angles of a triangle. We got all kinds of different things with triangles. If I know all 3 sides, then I'm not necessarily going to find the measure of the angles, but I know which one's the biggest and which one's the smallest. So like on this one here, really pay attention to the wording. This one goes smallest to largest. Number 19 goes largest to smallest. So make sure you put them in the right order. If you don't put them in the right order, then you got the wrong angles listed first and second. So on number 18, if I go smallest to largest, I'm going to go to the smallest side. The smallest side would be 6. So the side or the angle across from 6 would be angle S. 9 is the second biggest. Across from 9 would be angle R. And then that leaves me 10, and across from 10 is angle T. Once again, not a lot of work to show, okay? It's just a matter of looking at the triangle, identifying small, medium, and large, and which one's the biggest. We can do the same thing for the angles. So 20 and 21 are the same, except they give you the angles instead of the sides. What if I only know 2 out of the 3 angles? Yep, we know there's 180 in a triangle, okay? So I can still find the third angle, so you got to find that third angle first, and then use it to find the shortest side to the longest side. 24 to 27, you don't have to construct. It doesn't say to construct a triangle. It just wants to know, can we construct a triangle? Is it possible? So in this case here, we're going to take the 2 smallest ones, add them together, and it must be bigger than the largest one. If that's the case, which in this case it is, 13 is bigger than 11, we would say yes, we can make a triangle. If it's not, we would say no. Make sure you're adding the 2 smallest ones. And then it's not always listed from smallest to largest. Like if you look at number 27, these are not the 2 smallest sides. 35 and 120 are the 2 smallest sides. So make sure you're adding the right 2 numbers together, because that can change your answer as well. (28) through 31 are all very similar. 2 things that we're going to do here. First of all, I would prefer that you write your answer like we did on Big Ideas. You're going to have 2 possibilities. We're trying to show the range of possibilities of answers here. And we're going to do 2 things. We know 2 sides. We want to find out what could the third side be. So we're going to do 40 minus 24. And we're going to do 40 plus 24. And so x has to be somewhere between those 2 values. Okay? That would be the way I would prefer that you write your answer. We also said you could do this, but I actually think this is a little bit harder or more work. X has to be bigger than 16, and x has to be less than 64. These 2 things are saying the same thing, just a little bit different way of writing it. Okay, real easily on problems like this, if I said that 23 is less than 25, I can compare the 2 sides. So then, as long as these 2 sides are congruent, this is the hinge theorem that we talked about yesterday, then I can say that angle 2 is less than angle 1. And that is probably the easiest way to say angle 2 is the smaller end. It's less than, right? If you want to actually write out the words angle 2 is smaller, I'm okay with that. But you can simply just write it as an inequality. And I'm totally fine with that. That means the same thing. You don't have to use any words. You can just write an inequality. Because on a lot of these, that's what we're doing. We're writing an inequality. For instance, if I come over here, the last 2 problems, compare TR and UR with an inequality. So I would say 22 is less than 24. I'm going to compare the 2 angles that were given. We also know that we have 2 sides that are congruent. So because 22 is less than 24, the side across from 22 is TR. And TR would be less than the side across from 24, which is UR. If you wrote this, that would also be the same, because you would say 24 is bigger than 22, so you could say UR is greater than TR. So there's really two different ways that you can write your answer. When would I use an equal sign here? What would the two angles have to be? The same, yeah. If they were both 24 or they were both 22, I would say they're equal, right? So if the angles are equal, the side lengths are equal. Yeah, but if one angle's bigger than the other, then one side is bigger than the other. That's all you have to do. So there's multiple ways to write your answer here. Just be careful of the sign and which symbol you use.